Good morning, children. Welcome to the physics class. This is Krishna Chaitanya, your physics teacher. Before starting the lesson, there is a small announcement. All of you complete the pre-test and post-test without fail. Now, today's topic: how to calculate net force from free body diagram. In last class, we discussed about net force. Then, what is free body diagram? Free body diagram is nothing but the diagram showing all forces acting on an object at a particular instant is called free body diagram. The diagram showing all the forces acting on an object at a particular instant is called free body diagram. It is denoted by FBD. Now, we will learn with a simple example. Let a car be moving with a non-uniform speed along a road. What are the forces acting on the car? What is the net force acting along the vertical direction? What is the net force acting along the horizontal direction? Draw all the relevant forces acting on a body. Here example is given. Let a car be moving with an non-uniform speed along a road. What are the forces acting on the car? What is the net force acting along the vertical direction? What is the net force acting along the horizontal direction? Draw all the relevant forces acting on a body. Now we will calculate the net force acting on a car. Observe the picture. Here, car is given. So before starting this free body diagram, first we have to draw x-axis and y-axis. For each and every diagram, we have to draw x-axis and y-axis to identify the horizontal and vertical directions. X-axis is nothing but horizontal direction, y-axis is nothing but vertical direction. So start the free body diagram with x-axis and y-axis. Now coming to the car. Observe the car. F is the force acting on the engine. F amount of force acting on the engine towards left side. So force applied by the engine is capital F. Next, friction is acting in opposite direction to the applied force, that is small f. We read about friction. What is friction? Friction is nothing but resistance of motion. Here the car is moving along the applied force direction, so the friction acting on the car in opposite direction. Friction always acts opposite to the motion of the body. Here, due to applied force, the car is moving left side, but the friction want to stop the motion, so it acts towards right side. Good. So these are the two forces acting along x-axis, means horizontal direction. Now coming to the vertical direction. Here two cars are in contact with road. So the normal force acting on the two tires in upward direction. The normal force acting on the two tires means at 2 points in upward direction. Next one, gravitational force. We know that always the gravitational force acts downward direction. That is W. Here in vertical direction, total how many forces are there? Good. 3 forces are there. What are those? Yes, N1 and N2, normal forces towards upward direction, gravitational force W towards downward direction. Okay, so these are the forces acting on the car. So this diagram is called as free body diagram. We call it as FBD, free body diagram. Free body diagram is nothing but all the forces which are acting on the car. The figure represents all the forces which are acting on the car. Here how many are there? In vertical direction, 3 forces are acting. N1, N2 upward direction, gravitational force downward direction. In horizontal direction along x-axis, 2 forces are acting. Force towards left side, friction towards right side. Don't confuse, force is capital F, friction is small f. Now net force along the x-axis, that is F net x. X represent here, the small x represents along x-axis. That is F small f minus capital F. That is nothing but a difference between the two forces. Difference between the applied force and friction. Good. Now coming to the net force along y-axis, that is vertical direction. In vertical direction, three forces are acting, N1 and N2. Two normal forces are acting in the same direction. So we have to add N1 plus N2. W, gravitational force, acts opposite to the normal. So minus W. Two forces are same direction, N1 plus N2. W is opposite direction. So N1 plus N2 minus W. So resultant force along vertical direction is N1 plus N2 minus W. I hope you understood. Now another example. See here, find the net force in the given figure. One block is given, from left side to right side 7 newtons of force is acting, from right side to left side 5 newtons and 6 newtons. Two forces are acting from right to left, 7 newtons from left to right. Now we will calculate net force on this block. Okay, so the force is acting from left side first, 7 newtons. Now forces acting from right side, two are acting, 5 newtons and 6 newtons. So we have to add those two, 5 newtons plus 6 newtons equal to 11 newtons. Now net force is equal to 11 newtons minus 7 newtons, that equal to 4 newtons. The net force value is 4 newtons. Net force is nothing but difference between the forces from left side and right side along the horizontal direction. Here left side 7 newtons, right side 11 newtons. So 11 minus 7. Okay, so we have to choose the big value first. 11 is the big one. So 11 newton minus 7 newtons equal to 4 newtons. So practice number of varieties of problems, then we can solve it easily. Thank you.